Good morning. Last chapter is a machine learning. Now we'll study this. Uh, Here it is only for to learn the objective of this sixth unit or machine learning is to know the importance of learning techniques. That's it. Don't go in detail in the before for this examination point of view. And just see, I'll no, first I'll tell the lesson plan of this machine learning techniques. First, we'll see the machine learning definitions and what is a machine learning and all. What are the different techniques are there? We'll see the machine learning definitions and what is the necessity of machine learning and why it is required and like this. See, as we know that the machine learning is a subset of artificial intelligence. So therefore, if machine should be, if machine has to be intelligent, then it has to undergo these two machine learning techniques also. So therefore, there are three different types of learning techniques are there. There are three different learning techniques. One is a supervised learning technique, another one is unsupervised learning techniques, and third one is reinforcement learning techniques. These are the major three classification of machine learning techniques, and supervised, unsupervised, and reinforced learning. See here, where regression problems will be there. Regression problems. See here, the types of problems which used this supervised learning techniques is regression and classification. Now we'll see the definition of regression and classification. What are the different types of examples of regression problem, and what are the different problems in which the classification learning supervised technique will be used. And next, algorithm for a supervised learning and how it works, and the definition of linear regression. Definition of linear regression. Next, definition of decision tree. Decision tree. And next, optimization. Next, gradient descent algorithms. Gradient descent algorithm. I'll explain. This comes under this supervised learning techniques. First one is we have to study about definition of here regression and classification and their examples. And next, algorithms. What are the algorithms used in supervised learning techniques and how it works? And the next is the definition of linear regression, and second definition is definition of decision trees. As here, this one is used in regression techniques, and decision tree will be used in classification. Next, optimization. This is also definition. After that, a gradient descent algorithm. There is some explanation is there. Some small mathematics is also there. I'll explain this gradient descent algorithms. And later on, unsupervised learning technique, machine learning technique, and this is the clustering problems and association problems. So here, this supervised learning technique is a one. It requires teacher. So under the supervision of teacher, under supervision of some data, learning has to be taken place. So therefore, it is called as a supervised learning techniques. Whereas unsupervised techniques, they don't have any supervision. So therefore, directly we just give the data, raw data, and huge amount of raw data is supplied to the unsupervised machine learning techniques, and it clusters and association based on some analysis. It draws some conclusions out of it and make use of that data and finally gives the conclusion. So therefore, this unsupervised technique is very uh, alike, very similar like a human brain. So we don't have any supervision while after analysis. First, human being comes under supervising techniques. The students are the examples of supervised learning techniques. These students will learn the concepts from the teacher or under the supervision of teacher. So therefore, the students comes under a supervised learning. They learn under the supervision of teacher. So therefore, this is the concept of supervised or supervised machine learning technique. Whereas unsupervised learning, we don't see automatically learn itself. So this is a unsupervision. And next one is reinforcement learning techniques, the combination of both supervised and unsupervised learning. I'll explain this. We have only a definition of this. So therefore, we'll see one by one. This is the first machine learning lesson plan. We have a supervised learning technique, unsupervised and reinforcement. And in the problems, first regression, after that a classification of supervised learning technique. And whereas in unsupervised learning technique, what are the problems of clustering and association? What is the definition of clustering, association, and examples of clustering problems, examples of association problems, and so on. After completion of this, and artificial neural network. This artificial neural network is same like a human being neural system, the brain system. So here, artificially, we should create a human brain to make decisions like a human. So we'll see this and how biological neuron system, how the biological neural system is biological neuron is converted into artificial neural system. So I'll explain this, the construction and what are the activation function and why, how this is acting like how this particular artificial neural system is acting like a biological neural systems and how it is able to take a decisions like a biological neuron system, like a biological neuron systems and all those things. So we'll see this one. After this, later on in this sixth chapter, we have only a deep learning, the definition of a deep learning algorithm, deep learning techniques, deep learning techniques. See, once again, this is a lesson plan, please. ఇట్లానే మీరు కూడా ఇలానే చదవండి. ఎట్లా అంటే మెషిన్ లెర్నింగ్ టెక్నిక్స్, దేర్ ఆర్ 3 డిఫరెంట్ టెక్నిక్స్, లెర్నింగ్ టెక్నిక్స్ ఆర్ సూపర్వైజ్డ్, అన్సూపర్వైజ్డ్, reinforced. In supervised, again we should concentrate on 2 techniques, one regression and classification. Whereas in unsupervised, there are 2 techniques, but in our curriculum we have only a clustering examples, clustering problems. So therefore, no need to concentrate on association for the examination point of view, right? So after that reinforcement learning, we have only a definition of it. Here also the linear regression definition and decision tree definitions and optimization definitions and gradient descent algorithms I will explain with the help of some mathematical tools. Next, we'll start a machine learning first. Machine learning is a subset of artificial intelligence that is mainly concerned with algorithms which allow computer to learn from the data of past experience on their own. This is a basic definition of algorithm, machine learning. Let's see, it's very difficult to try a line. Machine learning is said to be a subset of artificial intelligence that is mainly concerned with the development algorithms which allows the computer to learn from the data and past experiences on their own. And the term machine learning was first introduced in Arthur Samuel in 1959 and can define it and summarize. So this is a definition of machine learning. Machine learning enables a machine to automatically learn from data. So first we need to give a data and improve the performance from experiences and predict the things without being explicitly programmed. So we don't have to program explicit, we don't give any explicit programs to the machine so that it can learn. So without being explicitly programmed, it whatever data which we are providing to the system, machine learning system, and from that data, it draws some conclusions and improves performance from the past experiences and predict the things without being explicitly programmed. This is the basic definition of machine learning. This is a basic definition of machine learning. See, with the help of simple historical data, which is known as a training data, machine learning algorithms build a mathematical model that helps in making predictions and decisions without being explicitly programmed. Historical data known as a training data. So we have to train the system. So machine learning algorithm training data, through data, algorithms will be developed. Algorithms build a mathematical models. Algorithm builds a mathematical model to make predictions or decisions without being explicitly programmed. Machine learning brings a computer science. See, this is machine learning concept, this computer science and statistics together. By creating predictive models, and machine learning constructs or uses the algorithms that learns from historical data. The, the more we will provide information, the higher the performance. So if data is very large, if data set is very large, the performance of machine learning system is performance of machine learning system will be very high. So data is very high and performance is also very high. So why we require a machine learning is, so see, dealing with this such amount of huge data is not at all possible by manually. So human being cannot do this task as like a computer systems. Computers can take any at what an amount of data, and that can process it. But as we human beings, we don't have a capability uh, to process the data of in terms of GBs, terabytes, like that. So we don't have that much capability. So therefore, machines can do machines. So whatever the data, what large amount of data we provided to the machine learning system, and such like the performance is also becomes very high. And machine has ability to learn if it can improve its performance by gaining more data. So next is how does the machine learning work? How does the machine learning work? Machine learning, how does machine learning works? See, machine learning works. Let me take a brighter color, red. Okay. Your machine learning system learns from historical data, build a prediction model. Prediction model. It builds a prediction model. Algorithms build a prediction models or a mathematical model to identify what the input data it is. And next year, whenever it receives a new data, it predicts the output for it. The accuracy of predicted output. The accuracy of predicted output depends on amount of data, as the huge amount of data helps to build better model which predicts the output more accurately. And suppose we have a very complex problem where we need to perform some predictions instead of writing code for it. So instead of writing code to identify to make some predictions, predictions out of data. We just need to feed the data to generic algorithms. And with the help of these algorithms, machine builds a logic as per the data and predict the output. Machine learning has changed our way of thinking about the problem. The block diagram explains the machine learning algorithms here. Whenever we have a complex problem where we need to perform some predictions. So therefore, we don't need to write program to program for a predictions. You just give this complex problem is there, and the data related this complex problem is given to the generic algorithms, and these generic algorithms builds a logic out of the data which we provided, and based on that logic the output is predicted, and machine learning output is predicted. This is the working. See here, this is input data which we are providing to this machine learning algorithm, and these machine learning algorithms builds logic models, and based on logic models output will be predicted. Yeah. This machine learning algorithms learns from the data which we are providing, and this wherever new data is found, this is a new data out of logical after building a logical models. Now we'll see the uh, features of machine learning. See, machine learning uses data to detect various patterns in a given data set. So we are not explicitly writing any programs to get exact output or a required output for machine learning applications. We are just collecting data regarding that problem that is given to these generic algorithms. So it can learn from past data and improve automatically. This is the one features of machine learning technique. And next, it data-driven technology. Just we have to provide a data so that it can take a decisions. It's a data-driven technology. And machine learning is much similar to data mining, which is also dealing with large amount of data. It is also dealing with large amount of data. So machine learning and is similar to the data mining. Now see what is the need of machine learning. See, let us take a very complex problem is there. As we already discussed in a class, let us take identification of medical diagnosis, like medical diagnosis, identification of tumor in brain. So we have to give hundred numbers of images of this particular thing, thousands or lakhs of images. Then better the identification, correct or not? So therefore, working on lakhs of images of brain, is it possible by humans? It's not, obviously not. Therefore, we collect a large data and give to the system. Now, system can analyze this raw data for huge amount of data. So that's why we require machine learning. So the need of machine learning is increasing day by day. We know that. The reason behind the need for machine learning is that is capable of doing tasks that are too complex for a persons to implement directly. As a humans, we have some limitations, as we cannot access the huge amount of data manually. So for this, we need some computer systems, and here comes the machine learning to make things easy for us. And we take here we can make here we can train a machine learning algorithms. We can train a machine learning algorithms by providing a huge amount of data and let them explore the data. let them explore the data and construct the models and predict the required output automatically. The performance of machine learning algorithms depends on amount of data which we are providing to them. Data is very small, the performance will be small. If data is very large, the performance of machine learning system will be better. And it can be determined by the cost function. With the help of machine learning, we can save both money as well as time. So here, where actually these machine learning techniques will be used is on self-driving cars. Okay. Instantly, your humans can take a decisions, but machines should take a decisions out of the uh, surrounding atmospheric conditions and all those things. And cyber fraud detections where we use machine learning techniques, face recognitions, friend suggestion in Facebooks and friend suggestions in Instagrams and all those things, etc. The various top companies such as Netflix and Amazon have built machine learning models that are using a vast amount of data to analyze user interest and recommend product accordingly. Amazon, Flipkart, all these are they have built already machine learning models that are using a vast amount of data to analyze the user interest, recommend product accordingly. And next one is we'll see how supervised learning works. What is a supervised learning? Supervised learning technique. Here it works in supervised learning. I'll take otherwise. Yeah, in supervised learning techniques, these models are trained using labeled data set. This is very important. Where the model learns labeled means already we processed the data. The data is means we are getting, let us take if it is a brain identification of brain diagnostic problems. So we gave only that labeled data. So already this is not the data contains only specific uh, data set regarding specific problems. If it is hot images will be supplied to the machine learning. If it is brain data is supplied to the means this is a brain data. This is a labeled data. This is hot. This is a labeled data. Where the model learns about each type of data. Once a training process is completed, the model is tested on the basis of test data, a subset of training set. Test data is a subset of training set. So actually data will be there. This data is divided into two types. One is a learning data. And in the learning data, see if we use 80% for the learning, this is a 20% for the test data. So is a subset of training test. So this out of this only 20% will be taken as test data. The subset of training set. This is a test data and training data will be. And so if it is data is 100%, we'll divide the test data and some learning data based on this supervised learning, and then it predicts the output. Supervised learning models are trained using labeled data, where the model learns from each type of data. Once a training process is completed, the model is tested on the basis of test data and predicts the output. So yeah, we'll see some block diagram. Based on block diagram, it will easily understand. Here, this is a uh, block diagram of this is a block diagram of supervised learning technique. Black diagram. See here, this is labeled data. Means Here are some hexagons, and squares and triangles, and all these are different types of label data are there. Out of this, so we are labels. What are the labels which we have? So hexagon, square, and triangle. So first we make a model to train or classify this all different this labeled data, and see if it finds four sides and those are equal, then it is called as a square. If three sides are equal, triangle. If all six sides are equal, it's a hexagon like this. So, and this is a learning data or learning data. Here, this some test data will be there. This test data, and based on test data, first already these algorithms are learned from this label data labels, and this is called as a model training. We are training model training. After that, prediction has to taken place based on this test data. So here the test data, if test data is given, if square is given already, this particular model is learned by the label data. So if all four sides are equal, then it is called as a square. And the output will be displayed on a square. If we give a test data to the triangle, no, this particular model is already learned from the label data. If all three sides are equal, not equal, if it finds the three sides, then it is a triangle. If all sides of the triangles are equal, then it is called an equilateral triangle. So first, before prediction, we should make this model to learn all the possibilities. Therefore, we have to tell each and every fact about this square and each and every fact about triangles and each and every fact about these polygons. So in a fifth unit, we represented the data, knowledge representation regarding this uh, square, triangle and polygons. And this representation, based on this representation only, this model can understand, okay, or understand as many facts about and this labeled data. So direct the square cannot understood by this model. So square, all related facts about squares will be represented. That is called the data representation or a knowledge representation. And that knowledge representation is recognized here. And based on that knowledge representation, this model will get trained, and wherever we test data to the and predictions, it will becomes very easy. See here, suppose the explanation is given here. Suppose we have a data sets of shapes which include square, triangle, and rectangular, uh, hexagon, polygon, etc. Now, first step that we need to train the model for each shape. If even shape has four sides, then all sides are equal, then it is called as a square. Like this. So this is represented in a knowledge representation. This comes under a knowledge representation. And if the given shape has a three sides, then it will be labeled as. See, ఇది మనం కరెక్ట్ గా రిప్రజెంట్ చేసి దానికి మోడల్ కి ఇస్తేనే అప్పుడు అర్థమవుతుంది. ఓహో, దీస్ ఆర్ ద ఫ్యాక్ట్స్ అబౌట్ స్క్వేర్ అని, ట్రయాంగిల్ అని, రెక్సాగోనల్ అని అట్లా. సో కాబట్టి ఈ డేటా రిప్రజెంటేషన్ ఆర్ నాలెడ్జ్ రిప్రజెంటేషన్ ఇస్ ఆల్సో వెరీ ఇంపార్టెంట్ ఫర్ better understanding of artificial intelligence and machine learning techniques. Yeah, better in future. Now, after training the test data model using test set, and task of the model is to identify the shape. The machine is already trained on all types of shapes. Then it finds the new shape. It classifies the shape on the basis of number of sides and predict the output. And what are the steps involved in supervised learning technique is here. First, we have to provide a label data. First, determine the type of training data set, means a labeled label uh, data set. Next, collect and gather labeled training data. Labeled training data. Split the data set into training data set, test data set, and validation data set. First, data is divided into training data is divided into or labeled training data divided into data set, training data set, next test data set and validation data set. And determine input features of training data set. Determine uh, input features of training data set. Right? Input features of training data set which should have enough knowledge so that model can accurately predict the output and determine suitable algorithms of model such as support vector machine. You would understand what is the support vector machine later. Decision trees, etc. You have to give a suitable algorithm model and execute the algorithm on training data set. Sometimes we need validation set as the control parameters, which are the subset of training data set, which is a subset of training data set. And evaluate accuracy of model by providing data set. If model predicts the correct output, which means our model is accurate. And next, there are types of supervised machine learning algorithms, or there are broadly two classifications. First one is a regression, and second one is a classification. Regression algorithms are used if there is a relationship between input variables and output variables. Input variables and output variables. If there is a relationship between input and output variable, input and output variable, if there is any relation, then we use a regression technique. It is used for the prediction of continuous variable such as weather forecasting, market trends, etc. Below are some important popular regression algorithms under this. Regression algorithm used if there is only a relationship between input and output variables, and it is used for a continuous variable prediction of continuous variables such as weather forecasting, market trends. And some examples of regression problems are linear regression, regression trees, non-linear regression, Bayesian linear regression, and polynomial uh, regressions. Out of this, we have only a linear regression. So we'll see the definition of linear regression. So first, next, after that, a classification. Classification algorithms are used when output variable is categorical, which means there are two clauses, yes or no, male or female, true or false, like this. See, output variable is categorical. This point is very important, which means there are two clauses. Classification means the clauses are two possibilities, whether true or false, yes or no, male or female, vegetables or fruits, or minds or machines, or males or females, etc. There should be some categorical. Output variable is a categorical. So therefore, in such cases, we use a classification algorithms. And some important classification algorithms were random forest, decision trees, logistic regression, and support vector missions. SVM is also called as a support vector missions and SVMs. See what are the advantages of supervised learning. See, with the help of supervised learning, model can predict the output on the basis of prior experiences. In supervised learning, we can have an exact idea of classes of object. And supervising learning model help us to solve various real-world problems such as fraud detection, spam filtering, etc. And disadvantages are supervising models are not suitable for handling complex tasks. And only some label data, some limitations are there. And supervising learning cannot predict the correct output if the test data is different from training data set. Means it learn, see, in learning data set, if you don't have any data set. See, it cannot predict the correct output if the test data is different from training data set. Test data should always subset of training data set. Then only it works. Otherwise, it cannot predict the output. And this is a subset symbol. This subset symbol. Exactly. Training data lost computation. Lots of computation time is required. And supervised learning, we need enough knowledge about classes of the object. It means each and every fact about the object. So that is knowledge. So we need enough knowledge about the classes of the object. If we don't have any knowledge regarding that particular object, we can't represent that particular knowledge. So therefore, this algorithm cannot understood what the features are. So therefore, it is may not able to detect. And next, this is all about supervised learning techniques. In unsupervised learning techniques, in this topic, we learned supervised machine learning in which models are trained using labeled data under the supervision of training data. But there may be many cases in which we do not have a labeled data and need to find hidden patterns from the given data set. So to solve such type of cases in machine learning, we need unsupervised learning techniques. See, supervised learning techniques use labeled data and supervision of training data. But there may be many cases in which we do not have a labeled data, need to find hidden patterns from the given data set. So to find hidden patterns, hidden features of data set, in that cases, we don't have any supervisions from data itself. We have to identify the patterns. So for such cases, we use unsupervised learning techniques. Here, as the name suggests, unsupervised learning is a machine learning technique in which models are not supervised using training data set. So we don't have any data set for training data set. Instead, models itself finds hidden parameters and insights. It finds hidden parameters, insights from the given data. It can be compared to learning which takes place in human brain while learning new things. It is almost like a human brain only. So we'll observe many different objects surrounding us, then we'll make decisions. Similarly, this unsupervised learning techniques also do the same thing. Unsupervised learning is a type of machine learning in which models are trained using unlabeled data set and are allowed to act on that data without any supervision. And this is a definition of unsupervised definition of unsupervised learning technique. Unsupervised learning cannot be directly applied to the regression and classification problems because unlike supervised learning, they have input data but no corresponding output data. The goal of unsupervised learning is to find underlying structure of data set, group that data according to the similarities, and represent that data set in compressed format. Here, regression and classification problems cannot be directly applied here. Like supervised learning, we have input data, but no corresponding output data. The goal of unsupervised learning is to find underlying structure of data set, group that data according to the similarities, and represent that data set in compressed format. Suppose unsupervised learning example, algorithm is given in input data set containing images of different types of cats, dogs. The algorithm is never trained upon given data set, which means it does not have any idea about the features of data set. The task of unsupervised learning is to identify the image features on their own. Hence, unsupervised learning algorithms will perform this task by clustering image dataset into a groups according to the similarity of between images. See, if this dataset is given to the unsupervised learning algorithms, first it clusters the images, means based on similarities of images, and these images will get classified first. The clustering will take place. Means these two will come to one side and these three comes to one side. This is a clustering technique. After that, so first, whereas in supervised learning techniques, we given uh, features of this particular dog and knowledge about, we provided each and every knowledge regarding about this dog and each and every knowledge about cats. But here, this unsupervised machine learning technique has to work on this data. We allow uh, act on this unlabeled data. Then base features will be formed out. Each one features, then clustering will be taking place. Clusters will be formed. These are dogs or like this. Why use uh, unsupervised learning techniques? Below are some main reasons which describe the importance of unsupervised learning. So, unsupervised learning is helpful to find some useful insights from the data. And unsupervised learning is much similar as a human learns to think by their own experiences, which makes it closer to the real AI. Unsupervised learning works on unlabeled data, uncategorized data, which makes unsupervised learning more important. And in real world, we do not always have the input data with corresponding output. So to solve such cases, we need unsupervised learning. There is one working of unsupervised learning. So you see that below this diagram, where we require this is a input raw data. This is not a labeled data. This is unlabeled data. Input raw data is given here, and here this model will draw some interpretation, and these interpretations means clustering has to take in, is applied to the algorithms. The algorithms and this will get processed, and after process will differentiate these from dogs and cats like this. So here we taken an unlabeled input data, which means it is not categorized, and corresponding outputs are also not given for this programs. Now, this unlabeled input is fed to the machine learning model in order to train it. The first, it will interpret the raw data to find a hidden patterns. Here we find a from the data, hidden patterns from this data, and then apply the suitable algorithms such as K-means clustering, decision trees, SVMs, right? There are different types of suitable algorithms are there. On these hidden patterns, some algorithms will be applied. These algorithms will allow us to take, once it applies to the super suitable algorithm divides into data objects into groups according to the similarities and differences between the objects. Like this, we'll get output will be like this unsupervised learning technique is output. So there are majorly two different problems in supervised learning. Unsupervised learning is divided into two types. One is clustering, and second one is association. Is association problem. So in different applications, we use this clustering approach and association approach. Yeah, clustering is a method of grouping the objects into clusters. Clustering is method of grouping the object into clusters such that objects with most similarities remain into one group and less and no similarities with the objects of other groups. Cluster analysis finds the commonality between the data objects and categorizes them as per the presence and absence of those commonalities. This is what about a clustering is. Whereas association is a rule, is an unsupervised learning method which is used for finding the relationship between variables in large data set. It determines the set of items that occurs together in data set. Association rule makes marketing survey more effective, such as people who buy X item are also tend to purchase Y. A typical example of association rule is market basket analysis. Market basket analysis. See, if we purchase yeah, if we purchase shirt, then associatedly we should also purchase pant. See, if we purchase a dog, we should we should uh, we should purchase dog food. Like this, there is a relationship. A learning method which is used to finding the relationship between variables in large data set. It determines the set of items that occurs together in data set. It determines the set of items that occurs together in data set. Like this, shut up and dog. Next, there are different types. There is some together data sets. Association rule makes marketing strategy more effective, such as people who buy X item, suppose a bread, and also tend to purchase bread and job, like this. A typical example of association rule is market basket analysis, like this. On this analysis, well, automatically we'll get some recommendations. Unsupervised learning algorithms. There are four different types of unsupervised learning algorithms. Are K means clustering, KNN means K nearest neighbors, hierarchical clustering, anomaly detection, neural networks, principal component analysis, independent component analysis, a priori algorithms, singular value decomposition, etc. Later in next higher classes, we are going to learn each and every. Uh, Whereas in Python program also, we are going to use this k-mean clustering, k-mean hierarchical clustering and anomaly detections, while classification problems, while clustering problems, we are going to use all these different types of techniques and algorithms. Advantages of unsupervised algorithms is unsupervised algorithm is used for more complex tasks such as compared to the supervised learning, because unsupervised learning we don't have any labeled data. Unsupervised learning is preferable as it is easy to get unlabeled data in comparison to the labeled data. Disadvantage of unsupervised learnings are, and unsupervised learning intrinsically more difficult than supervised learning as it does not have corresponding output. So we don't have a test data here. So that's why it is more difficult. The result of unsupervised learning algorithms might be less accurate as the input data is not labeled. Algorithms do not know the exact output in advance. So where we don't have any advanced output here. Why? Because we don't have any labeled data. So raw data will be there. First, it has to take some classification, clustering. After that, it has to take decisions based on commonalities and similar features. So the efficiency of unsupervised learning is also less. Why? Because we don't have any test data or labeled data. So we'll get exact output. These are the disadvantages of unsupervised learning techniques. Here, regression. Regression is a technique for investigating the relationship between independent variables, features, and independent dependent variables or outcomes. It is used as a method for predictive modeling in machine learning, in which algorithms is used to predict continuous outcomes. See, there is a relationship between independent variables. Regression is investigating a relationship between independent variables or features and dependent variable and outcomes. See here, what is this? Let us take f of x is equal to y. Means y is dependent variable and x is independent variable, and there is a relationship. So means between independent variables, these are independent variables and features. So if data is given, uh, let us take one square is there, right? The features of this, and each and every features is an independent variables, and there is output variable. What is the output variable? This one, dependent variable for outcome. So we are going to create a relationship between, we are going to find out what is the relationship between independent variable and dependent variables. Now here this independent variable becomes input and dependent variable becomes output. So therefore there is a there we are going to calculate, or we are going to find out what is the investigation, or we are going to investigate what is the relationship between independent variables and output dependent variables. It is used as a method of predictive modeling in machine learning, in which algorithms is used to predict continuous output. And common examples of machine learning regression model includes, and this follow, forecasting of continuous outcomes like house prices, stock prices, sales, etc. Predicting successful future retail sales or marketing campaigns to ensure resources are used effectively. Next, predicting predicting customer or user trends such as streaming services and e-commerce websites, etc. Analyzing test data set. See, these are the examples of regression models. So if we have to find, write down, give some examples of regression uh, algorithm techniques. So we need to write all those things. Predict interest rates, stock prices from the variety of factors, creating time series of visualizations, etc. Simple regression means we should what is investigation of relationship between input and output data or features and outcomes. Next, model classification means classification algorithms is a supervised learning technique and that is the used to identify the category of new observations on the basis of training data. The classification program learns from the given data set or observations and then classifies the new observations into a number of classes and groups such as yes or no, 0 or 1, spam or not spam, cat or dog, animal or human being, etc. The classes can be labeled as target labels or categories. Unlike regressions, the output variable of classification is a category, not a value, such as green or blue, fruit or animal, etc. Since the classification algorithm is a supervised learning technique, hence it takes a labeled input data, which means it contains input data from the corresponding output. The classification algorithms discrete output function y mapped into variable x. So y is equal to f of x, where y is a categorical output. The best example of ML machine learning classification algorithms is email spam detector. This is an example of classification. The main goal of classification algorithm is to identify the category of given data set. And these algorithms are mainly used to predict the output for categorical data. Yeah. Classification algorithms can be understood uh, using this below diagram. So here, the below diagram, there are two classes, class A and class B. These classes have features that are similar to each other and dissimilar to other classes. Means the similar features will be one side and dissimilar features will be other side. And all similar features of objects are comes under a class A, and other similar features or not similar ones will other class, and there is a classification. And the algorithm which implements the classification data set is known as a classifier. There are two types of classifications. One is a binary classifications. If the classification problem has only two possible outcomes, then it is called as a binary classifier, like yes or no, male or female, spam or not spam, cat or dog, fruit or animal, male or female, like. Whereas a multi-class classifier classification problem has more than two outcomes, then it is called as a multi-classifier. Classification of types of crops, classification of types of music, etc. comes under multi-class classifiers. So this is all about classification problems. Next is the definition of linear regression, simple linear regression. In simple linear regression is a technique which plots a straight line within data points to minimize the error between line and data point. And it is one of the most simple and basic types of machine learning regression. The relationship between independent and dependent variable is assumed to be linear in this case. This approach is simple because it is used to explore the relationship between dependent variables and one independent variable. Outliers may be common occurrences in simple regression because the straight line of best fit. Here. In simple linear regression is a linear regression technique which plots a straight line within data points to minimize the error between line and data point. It is one of the most simple and basic types of machine learning regression. The relationship between independent and dependent variable is assumed to be linear in this case. Means x f of x comma y is equal to linear. This has to be linear. So it means this is a dependent variable. Sorry, this is a dependent variable. This is an independent variable, and the relationship between these two was a linear. So that's why this is called as a what's a regression investigation of relationship between dependent or independent variable. And this, if this relation is linear, it is called a simple linear regression. Next, what is a decision tree? Decision tree is a type of supervised machine learning used to categorize or make predictions based on how a previous set of questions were answered. Decision tree is a type of supervised machine learning. It is used to categorize or make predictions based on how a previous set of questions were answered. The model is a form of supervised learning, meaning that a model is trained and tested on set of data that contains a desired categorization. A decision tree may not always provide a clear-cut answer or a decision. Instead, it may present options so the data scientist can make an informed decision on their own. Decision trees imitate human thinking, so it's generally easy for data scientists to understand and interpret the results. And read these definitions and write in examinations. Okay. Next here, the definition of optimization. Optimization is a process where we train the model iteratively that results in maximum and minimum function evaluation. It is one of the most important phenomena in machine learning to get a better result. Optimization is a process where we train the model iteratively that results in a maximum and minimum function evaluations. It is one of the most important phenomena in machine learning algorithm. It is a process where model iteratively that results where we train the model iteratively, repeatedly, results in maximum or minimum function evaluations.